there are many places where you can rent a boat around here in the Netherlands. Okay, so let's see. I see Francesco writing hi, Christian writing hi. I think we can probably start. It's 2 minutes in. I guess people will start to join slowly. Okay, so hello everyone. My name is Tony. I'm a software developer at SciTech IT Consulting, and you're watching SciTech DevJam. DevJam is originally a meetup group in Amsterdam where we gather together to discuss topics around technologies like programming and tech in general. And this is the YouTube version of it. Today we are connected with Robert, and Robert is an experienced backend engineer. And with him today we will explore the forgotten land of category theory, specifically functional programming with Scala. He has some pretty nice slides about it. And yeah, so without further ado, I would let Robert begin. If you have any questions for Robert about what he's going to present, please feel free to leave them in the live feed, and we will answer them at the end of the show. And yeah, said that, I'll pass the mic to Robert. Good luck, Robert.
Thanks, Tony. Yeah, so as you can see, my name is Robert Gabriel Dinu. I'm originally from Bucharest, Romania, and now I'm living in Amsterdam, the Netherlands. And I'm a senior software consultant at SciTech. And I will talk to you today about an introduction to the functional programming concepts in Scala. And I try to make it really simple, because I myself came to Scala from Java. And I remember that I was struggling to understand these concepts. Why functional programming? Because I think that the functional programming is often clear and simpler to once you understand. So I will show you today that Scala is a mathematical language. So that's why I have to talk just a little bit how this relationship is made. You will see how functional concepts are connected with category theory, which is a branch of mathematics. And my objective with this presentation is to give you a little practical taste of how it's like to write Scala code in a functional way. You will see that functional programming is just simple to reason about once you get the hang of it. That doesn't mean OOP or object-oriented programming is bad. You will see that we will be dealing with objects, especially data objects and inheritance. So, a short history of Scala. The inventor of Scala is Martin Odersky. He designed generics in Java, was released in 2003, runs on JVM. It's easy to write a domain descriptive language in Scala. The name Scala means that it's a scalable language. It has this property to grow with an increase of demands, because it uses multiple paradigm programming, like object-oriented and functional programming. And it also has meta-programming with macros. But in order to understand these concepts, I showed you this. Yeah, I show you this map of the category theory. The category theory, like I said, is a part of mathematics. This map is made by Martin Coupet. And you see the cost of category theory there in the bottom right. Then, what is this category theory? I will try to make, like I said, simple. Category consists of objects and relationships, or arrows, as you can see here, between them. An object can be anything. In this example, you can see that we have three objects, A, B, and C. And there is the first arrow, or this function f, that is going from A to B. That means that is f accepts the parameter of type A and returns the type B. And then there is another function g that goes from B to C, which means that accepts B as a type parameter and returns a C. So, and of course, you as a software engineers, you did this before. We can compose these two functions to go directly from A to C. So this example here, this code snippet, is just a function that compose the two functions, and it accepts an A type parameter and it returns a C. So the essence of category theory is composition. And you will see later that this relationship, these functions compose. And how we're going to compose. Like I said, category comes in all shape and sizes. The most basic category, it's the one without any objects, for example, an empty list, or if you're coming from Java, array list, an empty array list. There are sorted categories. So basically, this is the relationship between the objects that are sorted, right? You need to sort them somehow, and usually you use a function. So basically, that's the relationship between them. A graph can be a category, so you have the objects as nodes, and then you have the relationship between them, and then you form the category. What it does, it removes a lot of details. It abstracts over the elements. Because of the abstraction of categories, we can focus on the relationship between the objects. Then, let's move further to functional programming. In programming, we decompose a complex problem until we reach a simple level of detail that we can deal with. Then we solve each problem and recompose the solution again. Functional programming gives modularity, and a modular system has components that can be understood and reused. Of course, that in order to do that, you should have functions. So basically, in functional programming, you decompose until a function level, right? But in order to compose these functions, it's good to have pure functions. The functions that they don't have effects. Functions that avoid side effects, like writing a database, writing to a database, or writing to a file, or setting a field to an object. Those are not pure function, and we have to deal with this type of effects in a context. What a pure function is, where you can think of a pure function like the addition of two integers, right? It will always give you the same output given the same input. So that's the reason the pure function compose, because they don't have side effects. In order, because I want to show you some code examples. So in order to understand what are the codes examples about, I will present you something about Scala Generics. Again, really simple. So generic classes,
Robert,
or generic.
And another thing I always like to say when talking about functional programming that really helps me to understand it a little bit better is the difference in the statement. What I mean is that usually with object-oriented, when we write procedural code, we mostly write how to do operations. So we define step by step the operation we want to define, and usually it's all about the data modifications. Instead, with functional, it's really about what you want to achieve. So you kind of more describe your function, and you know that your function will return what it needs to do. Because as you will say probably right now, usually functions have no side effects, or at least they should have no side effects. Yeah, it's always helped me to define to say that functional programming is more about the what you want to achieve than the how.
Yes, that's true.
Okay. Yeah, go on. It was just a little comment.
Yeah. So something about generics in Scala, we can have generic classes. As you can see here, the class list with the T as type. And generic methods that take a type parameter within the square brackets. So this is a generic method. This is called companion object. Everything is, let's call it that everything is static when you define it as an object, right? The type parameter can take any data type that you want. Yeah, those questions marks, that means the method is not implemented. There's one more thing that I need to show you because we're going to use it in the code. So Scala has these three things: covariance, invariance, and contravariance. So in order to understand better, I have this example. So we have the class dog. Then we have two other classes. We have the class bulldog that extends dog and Labrador, right? Then if we say that we are talking about a covariance, that means a list of bulldogs extends a list of dogs. So I created this class here, the class covariant list of type A, and I put this plus. That means that is a covariant list definition. That means if I define a variable, like it is here, covariant animal list, of the type covariant list of dog, it also accepts whatever extends the dog class because it has the plus. If we are talking about invariance, that means the list of bulldogs and the list of dogs are separate. There's no plus here, so we have this class invariant list. That means you cannot, if you define a variable like this, invariant list of bulldog, you can't put an invariant list of dog or a Labrador. Then we have this contravariance. And as an example, I created this class trainer with a minus in front, and the trainer of bulldogs can be replaced by a trainer of dogs. In the sense that if we define a variable bulldog trainer, a trainer of bulldog, we can have a trainer of dogs. Of course, a trainer that knows how to handle dogs, it can handle a bulldog. So because you'll see this plus and minus, so you know what's that about.
So it looks like it's a little bit more flexibility in. It's a bit like an interface, but a little bit more flexible. So you can define a little bit more flexibility in terms of extending a specific class.
Yes, and this is because Scala also has this strong type system. Mm-hmm. So you can define your logic. Of course, we won't go into that detail today. We can define your logic in the types, and if everything compiles, that means it's correct. This is the idea in functional programming in Scala.
Got it.
Yeah. So we are diving into the functional programming concepts with monoid. What's a monoid? A monoid is a set, because now we know, I showed you category theory, is a set. It has the concepts behind arithmetics. And as you can see here, it has to obey two laws. That means it has an operation and an empty element. And A with the operation B must be equal with B operation A. So that means it is a binary associative operation. You will see that the sign here, it's made on purpose to be weird, right? Because you can define whatever operation you want. So here, as an example, I defined it as a addition between elements, and that's why we have the plus here. So A plus B must be equal to b plus a. And of course, if you do an operation with an empty element, you should get back the same value. Let's go back. Let's go forward to the code actually. And the monoid. I will make it bigger. I guess it should be all right. So we have this trait. We have a monoid of type T. Usually you will see that around tutorials or books of Scala, you will see the type actually the types are A, B, C. So starting with A, but since the majority of you are coming from Java, I took this.
Yeah, sorry, Robert, short questions from non-Scala programming. What is a trait?
Yeah, good question. It's like an interface.
Okay.
More, but it's like an interface. So in this example, we are treating it the same. So what we need to do, we will create a monoid of string and a monoid of int, right? We have this monoid ops companion object. So all you need to do is let's try to define it. I'll remove all the comments. Okay, we need to implement this method. Maybe, yeah, so we will define this monoid as a concatenation. Oh, yeah, I made a spelling like that. Of course, the string object already has something like that. So we are defining this operation between A1 and A2 as a concatenation between strings. So we are just using this plus sign. What will be the empty element for a string if we are thinking in terms of concatenation?
Empty string.
Empty string, because it bugs me. Okay, now we have to define a monoid of int in the context of addition. So the same thing, remove the comments, easier. Yeah, it's easy, we just sum two elements up, right? And the empty for addition, of course, is 0. Right. Okay, now I also created some tests because I always think that the tests will help. So here we want to be sure that we can handle concatenation. So I'm defining this list of strings. You can see that I also put the empty string, but I can also use the empty element that I defined in my string concatenation monoid.
Mm-hmm.
And then using this folding, this reduce operation, because if we have a binary operation, that means we can reduce elements. If we have a category, right? A list of strings. So this definition of a fold right in Scala, it takes on the first position here the accumulator. So in this case, we will take the empty element from our string monoid. And on the second part of the fold right, it expects a function that will take two parameters on the same type, so two strings, and it will return one, a string. So basically we will use our string monoid operation to reduce, right, to concatenate. And of course, if we concatenate this list of strings, we're gonna get this result. And I also have a test. What will happen if we're gonna use an empty list and our operation? This is the shorter way to write this function, but I just wanted to have it like this so everyone understands better.
Mm-hmm.
Let's run it. Yeah. Let's see if it's running. Okay. Yeah. So this test passes. We have green. I like the green color. Now we're going to test the integer monoid in the context of addition. We have this list of integers. This is the int. Yeah, this is the integers, the integer class in Scala. So I created this list. We are using the integer monoid that we defined previously. As you can see, I put the short version here, but it's exactly the same as here. And we're gonna use it to sum our list of elements, our category. And I also have a test with the empty list of integers. So let's run it. The purpose, yeah, it passes. The purpose of this is that we can reuse. So I'm going to show you how we're going to reuse. Besides that, you can reuse the monoids that are already there. You can compose monoids. So we're going to take our string monoid and our integer monoid to make a new product monoid. We're going to define a list of tuples, a list of pairs of string and integer. So we have, you see here, some programming languages and the number. Of course, Scala is on the first place. Joking. And we're going to define this product monoid. Here, in this product monoid, we don't care about the types, but it's a function that is generic. It has A and B as types, and it uses two monoids to combine it into a pair of a new monoid. So let's define it based on our trait. So now we need to compose, right? On the first place, we need to have A. So we're going to compose the first part of A1 and a first part of A2 using our already given monoid.
So this reminds me a bit of a higher order function, by the way. The concept.
Oh, yeah. Actually, is not quite a higher order function, because you don't. A higher order function is the function that accepts parameters as a function and returns a function. But here we already have a class.
Mm-hmm.
It might look like with all the weird signs. So the first part of A1, this is how you take the first part of a pair in Scala or a tuple, and the first part of A2. Okay, and we are creating a new tuple. So this is just the first part of the tuple. Now we need the second one. We're going to use the B monoid for that, and the operation, and A2. Yeah. Okay. I don't have any error, so it must be okay. What we're going to do with this? Well, this is even simpler. We're going to take the empty from A1 and the empty for B2. We're going to move back to the... Okay. So we have our list of pairs, and we want to concatenate the strings and do the addition of the integers. We already have our product defined. And let's run the test. And we used the two elements, the two monoids defined. Let's move further to the functor. What's a functor? Well, a functor is a mapping between categories, because, okay, you have a list of strings, but maybe you want a list of integers out of the strings. So basically, you're mapping from one category to another. Yeah, so there is this function map. It's a generic function, a generic method. It has two types, the T and R. R is the return type, and T is the input type. It takes a functor of F type T, and also a function that will go from T to R, and it will return a functor of type R. So this is the only law that it has to obey. If we are using the identity function here, so we are returning, the function accepts a T and returns a T, it will return the same functor. going back to the code for functor operation. Okay, so we have this trait now, a trait functor, and we want to implement this functor for our lists. This is quite easy because the list in Scala and also I remember that Java has something like that with the map already has this map function that you can use. So we are defining the functor of type list. Remove all the comments. So all we need to do, we have our list, right? So we're gonna do we're gonna call a map method on the list. So we're gonna map all elements. So this is the map function accepts a function, right? The list. And we're gonna apply. Yeah. So we are gonna apply our function to each element on the list, and it will give us a list of R. Let's see how we're gonna do that in.
Wow, this is all in one line. This is a very, very dense operation.
Yes, and I tried it to. You can.
No, but this is the power of the language, right? So here you can see in one line you define quite of a complex operator, if you want, this functor or concept.
Yeah. Okay, this is the functor. So in this case, we have our list of category of strings, right? Same PHP. I'm sorry for PHP. I don't like it myself, but I just put it here. So we have these strings, and we want to have a list of the tuple of the pair string and int. And what we're gonna do, we're gonna just call the length method on the string. So we are using our function. Yeah, usually you don't put all the types. Usually you don't write, this is for this presentation, we write it without the types defined because you have this way of defining variables, but this is easier to understand. We are using our list functor, and it accepts a list on the first element for the map method. And then this is the function that will help us create our pairs. So on the first position, we are just returning the string as it is. And on the second position, we are returning the length. So we are running the test. So here it is. And this is just to test the law of our functor. This is the identity function. So what it receives, it returns. And of course, the result should be equal to the same input, let's say, right? Because it doesn't do anything. Okay, let's go further to more interesting stuff. So, monad. Well, it's a functor. Two extra
So
methods.
if you guys haven't lost what you were saying so far, now I guarantee you're gonna get lost.
So I was reading a lot just to be able to understand the monads and why we have monads.
For me, it's interesting. I'm not a Scala developer. I never played much with Scala language, but what I can tell is that it's really dense language. It's really powerful. It allows you to abstract a lot of concepts, so you can really create powerful automation and be at one level higher if you like. So I think Scala developers really likes to play more with types and abstract hierarchies, and writes very little code because it's very, very dense once you get it working.
Yes, and that's why if you're doing too abstract, if you have like a huge method and you define it, if you don't define your variables in a readable way, the person that comes after you, it won't be very happy, let's say. It's easy to write messy code. That's why if we are all that we are thinking in these functional concepts, we are all thinking like that. It's easier to understand. Like the design, who is it called in OP? From the book of Gang of Four, the design patterns. Design patterns in OP understands all of us. Help us to understand better the code that everyone is writing, because you follow these design patterns. So back to monad. We have
this monad.
The flat map, it's basically composed of two processes. Let's say it's flatten is a short for flatten and map. As you can see, all monads are functors, but not all functors are monad. Examples of the monads that are already in Scala, it's list, option, stream. I define this map here, but we don't have to use it. There are two main methods. There's the unit function that you can see in this trait. It helps us create a monad. Basically, it gives a t, right? A value of type t, and it will create a monad of type t. And then, of course, we need to define our flat map. Let's go to monad operation. Here it is. So this is our trait. It accepts, this is a higher kinder type. So it's a type that has a type. So it is what it is.
And what's the underscore? What's the underscore?
You don't need a type that is in its type. So the parameter of m, we don't care.
Okay.
In order to understand better, I define this maybe data type is like option in Java. And the name, maybe it's from Haskell, basically. So we have this sealed trait. You can just ignore the sealed. It's just here, but not for this purpose. Then we have two data types for this maybe. When we have a value, we have this just type with a value inside it, v of type t. And if we have an empty, that means there's no value, we have a maybe of nothing. This is just coming from, it's a type from Scala. So now we have to implement this monad of maybe. So you can think of this maybe, it has two states. It has the one state that has a value and the other state that doesn't have a value. Let's define it. So for the unit, calling map. This is I know you. I think you know this coming from Java. I just had to redefine the map because it extends the functor, like I said. What's unit? Unit means it gives you a value. If you have a value, then you have a just type of that value. Then, if you want to do a flat map on the maybe, we need to see what type of maybe we have. If we have a value inside it, or if you have an empty. We're gonna do a little bit of pattern matching. Pattern matching is like a if condition. I think Scala developers will hate me for this, but I just make things. I just want to make things simple.
It's a fancy switch case.
Yes, yeah. So if empty, if this maybe is a just of value, what we're gonna do? We need to return a maybe of R. We already have this function. It takes a T, type T, and returns a maybe. So it's just simple. We're gonna call F with our value. It also does unboxing. So instead of doing call this V, right? It does unboxing for you, so you just pull out the value from the just.
Mm-hmm.
And if you have an empty, what we're gonna you can't apply a function to an empty, right? You return an empty. You don't apply the function. Okay, let's see how we can test it. In order to test it, we have this higher order function that it will return a function that accepts an integer as a parameter, and it will create a maybe of double. You will see that basically it's a division by 2. So of course, if you have a 0, instead of throwing an exception, it will return an empty. If you don't have a 0, then it will return a just of the value. Okay. So we have our maybe monad. We are creating a maybe of integer.
Can I ask a question, Robert? When you are defining that if-else statement, that's basically just recognized as just one operation, right? So you're just saying that that's a lambda. I'm talking Java now. I'm using Java terms. Yeah, in this page, where it says I arrow if I equals 0 empty else just. So that's just one line, right? That's why you don't have to define any or open any curly braces.
Yes, actually we can yeah, you can open it if you want.
Mm-hmm.
But yeah, this is easier to write it. So I is a type integer.
Mm-hmm.
So it's a function that you can also write it like this. So you can write it like integer, something like that in a more simple.
No, it's okay with the types. I just wanted to understand. It ends where it says just I divided by 2.
Yeah, this is the value that it's coming from the flat map. So we have this maybe of int, and then we're going to use our defined flat map method that accepts a monad on the first position, and then let's call it inside monad. And it will take in the flat map, you will take the value that is inside the monad. So in this case, this 42, right? Because you have this maybe, and this maybe it's put here, and then you call your function with this, with the same value that is inside the monad. So it will recreate the monad for you. That's why you are starting with a monad of int, and you will get a monad of double, because this is what what this function does. It accepts an integer, and with the help of flat map, you already have that. It's pulled out of the context, and it will do the operation. So if we okay. Demos. Let's see. Yeah, I think I need to define it also here because it extends the functor. Okay. Otherwise, it won't compile. Okay, run it again. Yeah, so you can see we divided 42 by 2. If we had defined a function like this, that will take an integer, in this case I, and it will return a double, I divided by 2, it can be 0 and everything will break, sorry.
So it's basically like a division function that is smart enough to understand when there is a 0 or not.
Yeah, and you will have in a real world example, you will have more complex monads that will deal with exceptions, that will, you can put a message, it has 2 parts, but yeah, it's even more beautiful. Okay, I want to show you on the last, I hope everyone, they are still there. I want to show you a real world example. So we are using, in order to interact with the outside world, in our example here, we are using these repositories. These repositories can interact with the database, for example. We're going to use a monad. We're going to use the IO monad in a very simplistic way from the cats library. So what this application does, it's a console application. It has 2 repos defined. It aggregates the data and prints the data. We have these 2 data types. This is a case class. Yeah, you can see it's very easy to define a data class. It's like a DTO. You can think of, instead of using Lombok and annotation and stuff like that, you can use this case class. This is the order. It has an ID, a date, time, and a list of products IDs. Yeah, and then we have this product data class. It has just an ID, the name, and the price. Because yeah, I want to show you this as simple as I can. I created these repositories that are in-memory repositories. So I'm creating this list of products, 10 products, and then 2 orders. And I'm gonna map. I'm gonna map a product with its order. I want to show you how this looks like. So we have a trait or an interface of order repository of this type of monad, and it will return. We have this method orders, and it will return a list of order, right? But in the context of the monad. We don't know which monad we're gonna use, right? But when we create our implementation, this is a case class of order in memory repo. It extends this interface, but with the help of IO monad from cats. So basically, these IO monads help us interact with the outside world, to the world that has effects. So everything is wrapped to the monad. This is coming from the library. The same for the product. It returns a list of product, but in a monad context, so in IO. This is just the basic stuff. We are just pulling some data. This is how you define a program flow with our monads. Basically, this is a flat map. You see, it's a syntactic sugar from Scala and from Cats library. This arrow here is flat map. So what it does, it takes the orders from the order repo, puts them into this variable. Then it uses this retrieve function that accepts an order, that accepts a list of orders, and also the product repo. So it combined together these 2 data types into a order products data type. And this sequence here, it's also from Cats library. It helps us to transform a list of IOs, a list of monads, into a monad of list. Yeah, this is like magic, let's say. So this is it. So this is the program. you will see that everything it has the IO, so it has this context. This IO is very powerful. It depends how you use it. It handles exceptions, it handles timeouts, it's cancelable. It uses parameter. It helps you with parallelization. It uses fibers, which are green threads. So it's very, very powerful. Let's run it. I'm extending this IO app that does all the things for me in order to run this application. I'm creating a list from 1 to 10, and you see that everything is it's returned. We have this order 1, and we have this list of product IDs here, 1, 2, 3, and our products with the product 1, product 2, product 3. Just a small, what will happen? We have this timeout, 5 seconds. That means our application has to run in 5 seconds. What will happen if it's not running? And this is my last. Right? Let's say that the database takes too long for the orders, to get the orders from the database. Run it again. So we didn't change anything. Waiting, yeah, maybe 5 seconds is too much. And it's failing. Of course, using this library, you can do a retry. You can, without modifying your code, without modifying your logic to aggregate things or to how you pull the data and stuff like that. Everything is inside this IO context or monad. And I think so something about cats. Conclusions, let's say. Functional programming is not easy. Scala, especially if you're coming to Scala. First, I was writing OOP code in Scala. It was very weird. But once you understand all these concepts, you will see that it's very easy to reason about. And there are also some functional programming libraries I saw also for JavaScript. And if you want to dig more in Scala, there's Zio or HTTP4S. What I learned, if you have a huge amount of data that you're processing over Hadoop with Spark, don't write Java. You're gonna hate yourself. I tried it once, and you're gonna lose your mind. It's way better to use Scala. Scala is not a silver bullet. You use the right. Everyone is saying that. I will say it again. Use the right tool for the right job. I didn't see the benefit in using Scala until I went back to Java for 1 year, and now I'm back to Scala, and I like it. So that's it from my side.
Nice. Thanks. Thank you very much, Robert. Let's bring back this view, me in place. Thank you very much. It was very interesting. It was a little bit alien for me, if I have to be truthful, because I'm not a Scala developer. I know barely the surface of functional programming, but I tried to follow. It was interesting. I would like to know if anybody else managed to follow, or it was also alien for them.
Do we still have viewers?
Sorry?
Do we still have viewers?
We still have viewers, yes. We have 16 people watching. And let's see if we have any questions so far. So I see Georgie is writing if you would recommend a book about Scala.
There's the one book that everybody is reading, and I read it when I had to understand better. But I can't point the name. But I can.
Okay, we can also add it in the description or in the comments after. Okay. I also have a question. So I saw that it's a very powerful language. You have to get to know it. So it's a really different paradigm shift from regular object-oriented programming and procedural programming, like most of Java developers do. So, in your opinion, what is the real concrete benefit that you found? So besides, of course, being able, or maybe could you describe a little bit why do you think that writing Scala code is better in the context of Hadoop, for example? So big data kind of context. Just to get a grasp on what is the benefit of using such constructs like these three big chunks that we saw today.
Yeah, so when you're writing ETL jobs in Hadoop, you're getting data from one place to another, you're transforming it, you're mapping, right? You're doing a lot of this operation. So if you want to do it, okay, Java also has this var, that's as a var, so you don't have to put a type. Everything in Scala is immutable. So you don't have to care about the multiple threads modifying your data. This is one reason. You don't have to put types everywhere. Of course, like I showed you, it's good to understand, but once you have your pipeline defined, then everything is not so verbose. It's condensed, and it's imagine that you have to do a lot of calculation, summing, grouping, stuff like that. So you basically do a lot of you can do a lot of mathematics with your data. So it's in a very small space that you have in your IDE. You can have your whole flow, and because of this reusability of components, you don't have you usually use pure function, and then it's easy to compose, to put objects together. You decompose everything into small pieces, and then you compose the whole structure, and it's also easier to test, because if they are pure functions, you don't care about side effects, mocking stuff, or state of objects. Or
so basically what you're saying is that by abstracting into function, everything is a function, and putting as much as possible aside the side effects by using libraries such as cats, it is way easier to deal with errors, and it's way less verbose to use. So you can write much more dense code and simpler, if you like, expressing what I was saying before, more the what you want, rather than dealing with all these things like throw exceptions or side effects in your data, or defining everything final, these sort of things. So all these things are all out of the box with Scala, kind of. So it's a really, really powerful tool, but you need to learn a bit how to use it before you start getting proficient with it.
Yeah, it takes some time, but I can tell you that after you understand everything,
And let's see if we have some more questions. So Marian says category theory was easier than Scala itself. Lucas says thanks, was great. And Georgie say I would watch more video about Scala. That's actually very interesting. I would like to ask you guys, if you want to see more content Scala related, please leave a comments, or also here in the live feed right now another comments, and we will. I know that Robert has a lot of material about Scala. We actually had to really select what to present today. So definitely we can make a part 2 about Scala, and
we can make things simpler and leave the whole functional programming concepts. We can focus on the Scala syntax they want.
Yeah, because today we just we really focused on the functional concept, and we didn't really go through the Scala language. I was asking some questions myself, but today talk was more about functional concept applied to Scala. So not about Scala itself. So let's see, we have more questions. So Aaron asks, how does Scala compare to Kotlin? So far, I think most concepts are also available in Kotlin. What would you recommend, Kotlin or Scala, or a combination of both?
I'm not so familiar with Kotlin, to be honest. So all I know that they are also doing functional programming mindset in Kotlin, like they are doing in Scala. Yeah, you can imagine that I'm biased, so I can't say like, because I already know Scala and I don't know Kotlin. So if someone will ask me, yeah, I will recommend, I don't know, Scala, but it also depends what you're gonna do. And the team or the company that you're working on, if there are more Scala developers or there are Kotlin developers, of course, you won't change the mindset of everyone because it's hard to move from one language to another. To tell you the truth, I looked at Scala 3 and I like it. So they are doing some nice stuff over there. So for sure, I will use Scala.
Yeah, in my opinion, I think also Kotlin is a great language, but probably they are two different tools for two different causes, if you like. So Scala, I see it as a, like a Hermes Swiss knife, where you have really a lot of power and you have a lot of tools and concept that you can use to optimize to the max your code in a functional way. Instead, with Kotlin, what I see is more of a direction of taking Java and making it prettier. So for sure, is as Robert said, it's definitely applies the direction of functional programming. Kotlin and encourage the use of functional programming. It has very interesting syntax, but I think Scala is more powerful. So it has a lot more in that sense, at least for what I got so far.
And also because of the data part. So if you're doing data, if you're a data engineer, machine learning engineer, and I'm doing something like that right now, and I did it in the past, Scala, it's more powerful.
Yeah.
Sorry guys.
No bias at all here. Huh? Okay, we have another comment from Jonathan. It says, for 1 second I thought we were talking about React, composition of small components to create something big. Oh, very nice. So we have also some front-enders joining us. That's great. Yeah, indeed. I mean, in the end, all programming languages are kind of basing on similar concept, and it's natural that they all refers to the basic of mathematics, and in the end it's always the same.
Yeah, I saw that there's a lot of push towards the functional programming, and I think because also now we have more powerful processors and we have more cores. So we have to think about this thread handling, and to be sure that we are not modifying more threads are modifying the same object or the same data and stuff like that. So I think it's easier also in this context of asynchronous programming to think in a functional way than in object-oriented. Then you have to be careful to not modify the state and stuff like that. And there's a myth, and I also had that, when you add an object to a list in Scala, it creates another list each time. So that means if you add 10 objects, you'll have 10 lists. But not all the 10 lists are referenced. So that means the garbage collector collects the garbage, right? So it's not the case. The garbage collector, especially in the latest version of Java, they are powerful enough to not have to worry about this garbage that functional programming creates in a way.
Yeah, totally true. I heard it's very optimized, the Scala one. Okay, let's see, more questions. Looks like we don't. Just Georgie says yes please, so we'll probably come up with part 2 of this one in the future. Okay, nice. So I think at this point, if we don't have any more questions, I would close. We barely crossed the 1 hour mark.
Yeah, I try to keep it short.
No, it was great. Thank you very much, Robert, for joining us today and show us all these interesting things that were a bit alien to me, but very, very interesting. I hope you guys had fun watching. And again, if you have any more suggestions or you would like to see more about this topic, please also leave a comment on the video after we will publish it after the live. And yeah, said that, I would wish everyone a nice evening, and I'll see you in the next appointment. At the moment, we don't have any planned dev jam for the future, but we will see each other probably in a couple weeks. Okay, have a nice evening, everyone, and bye, Robert.
Have a nice evening. Thank you for organizing.
You're welcome.